The mysterious city of Machu Picchu is no longer occupied. It's been empty for nearly half a millennium.
You began to see within this the outline of a doorway.
And we're talking about ultimately being able to recover the power that Pachacute.
Machu Picchu has not been lived in for close to 500 years. Every day, thousands of people walk its terraces, photograph its stone walls, and stand at the same overlook that appears on a million postcards. And every day, almost none of them realize how little of this place has actually been explained. Not discovered, explained. Because in the last few years, 3 completely different lines of research using DNA sequencing, laser mapping from the air, and centuries-old engineering records have quietly forced historians to throw out a large part of what they thought they knew about who built this citadel, who lived in it, and why. And now, just as those answers are starting to come into focus, Peru is racing to open the floodgates to millions more visitors than this valley has ever seen. That collision between what scientists are still trying to understand and what the government is in a hurry to build is the real story here. Not a hidden treasure, not a buried secret chamber. Something quieter and in its own way more unsettling, a 500-year-old mystery that is being outpaced by a construction deadline. To understand where this starts, you have to go back to a genetics lab, not a jungle. In 2023, a team of researchers from Yale, the University of California, Santa Cruz, Tulane, and the National University of San Antonio Abad in Cusco published the first genome-wide DNA study ever conducted on people buried at Machu Picchu. The team, led by archaeologists Lucy Salazar and Richard Berger, along with geneticist Lars Fahrenschmitz, sequenced ancient DNA from 34 individuals interred at the site, comparing them against burials from the wider Cusco region. For decades, the working assumption had been simple. Machu Picchu was a royal retreat built for the Inca Emperor Pachacuti, staffed by attendants likely drawn from the surrounding highlands. The DNA told a different story. Only a small number of the people buried at the site traced their ancestry to the Cusco Valley or the nearby Lake Titicaca region, the traditional Inca heartland. The rest carried genetic signatures from all over the empire, the northern and southern Peruvian coast, the Andean highlands, and most surprisingly, the Amazon. Roughly a third of the individuals studied carried substantial Amazonian ancestry, with genetic ties tracing to at least 2 distinct zones deep in a rainforest, hundreds of miles, and a brutal vertical climb away from the citadel's cloud forest setting. What struck the researchers even more was how mixed many of these ancestries were. This wasn't a population where different ethnic groups lived side by side, but stayed separate. Individuals buried in the same tomb, sometimes the same cave, carried DNA reflecting ancestry from entirely different corners of the empire. Berger, who spent decades studying the site, described the population as genuinely cosmopolitan, people from different backgrounds who lived together, had children together, and were buried together in a pattern that doesn't resemble a typical agricultural village or even a normal royal court. According to the research team, most of the people in this study weren't nobility at all. They were likely what Inca administrators called retainers, workers and attendants drawn from across the empire through systems of forced resettlement, brought to Machu Picchu to serve and maintain the estate for the ruling family. That reframes the entire site. Machu Picchu wasn't simply a mountaintop palace with a skeleton staff. It was a functioning outpost of an empire's labor and resettlement machinery, deliberately populated with people pulled from thousands of miles in every direction. Why the Inca state invested that much effort into assembling such a genetically diverse workforce at one remote site rather than relying on local labor is still an open question researchers are working through, and it's a legitimate one, not a cover story. The honest answer right now is that nobody fully knows. While the DNA results were reshaping how historians think about who occupied Machu Picchu, a very different kind of investigation was reshaping how much of the site even exists on any map. Machu Picchu, as most people picture it, is the compact core most visitors walk through in a few hours. The main plaza, the temples, the famous terraces cascading down the mountainside. But the surrounding national park sprawls across nearly 32,000 hectares of cloud forest, most of it never systematically surveyed, because dense vegetation makes traditional excavation nearly impossible in large sections of the terrain. That's where LiDAR comes in. LiDAR, light detection and ranging, works by firing millions of laser pulses from a drone or aircraft toward the ground. Most of those pulses bounce off leaves and branches, but enough slip through gaps in the canopy to hit the actual ground surface. Processed together, the reflected pulses build a three-dimensional map of what's underneath the vegetation, effectively letting researchers strip away centuries of jungle growth without cutting down a single tree. In surveys conducted in the area around Chacabamba, an Inca ceremonial complex within Machu Picchu's broader archaeological park, a team from University of Warsaw's Center for Andean Studies, working with Peruvian park authorities, used drone-mounted LiDAR to scan terrain that had never been closely studied because it was simply too overgrown to walk through safely. What they found were roughly a dozen previously undocumented structures, the foundations of buildings, small platforms, and sections of channel systems that had never appeared in any survey, any map, or any record going back to Hiram Bingham's original exploration of the site in 1911. Researchers on the project believe some of the newly identified buildings may have housed the people who maintained the ceremonial water complex nearby, since evidence recovered from earlier excavations in the area, including tools associated with weaving, suggests women played a significant role in overseeing that part of the site. It's a modest-sounding finding on paper. But sit with the implication for a second. After well over a century of intensive archaeological attention, after millions of visitors and thousands of published papers, a research team flew a drone over ground everyone assumed had already been accounted for and found buildings that had simply never been seen. If that's true for one surveyed section near Chacabamba, it raises an obvious and still unanswered question about how much of the wider park, most of which has never been scanned this way, is still sitting there undocumented. The third piece of this doesn't come from new technology at all. It comes from looking harder at something that's been sitting in plain sight the entire time. Structural engineers who have studied Machu Picchu's construction, most notably the American civil engineer Kenneth Wright, whose team spent years surveying the site's water systems in 1990s and 2000s, found that what tourists see above ground is only part of the story. Beneath the terraces that everyone photographs lies an extensive, carefully engineered drainage system. Layers of graded stone and gravel that channel rainwater away from the buildings and terrace walls, preventing the kind of erosion and water damage that would otherwise destroy a mountainside settlement within a few rainy seasons. Combined with an integrated water supply system, a stone-lined canal that carries spring water down through the site to a sequence of carved fountains, this hidden infrastructure is why Machu Picchu has survived 5 centuries of Andean rainfall largely intact, while countless other archaeological sites from the same era crumbled or washed away. The Inca built this without iron tools, without a functional wheel for transport, and without mortar, relying instead on dry stone construction, so precise that in many walls you still can't slide a knife blade between the stones. Engineers who've examined the site have repeatedly pointed out that the underlying principles, controlled drainage, graded fill layers, foundations designed to flex rather than crack, mirror techniques that modern civil engineering didn't formalize until the 20th century. None of this required lost technology or unexplained science. It required an extraordinary depth of empirical knowledge about stone, water, and mountain terrain, developed and refined by Andean builders over generations. That's not a smaller story than a mystery. In some ways it's a bigger one because it's real, documented, and still standing. Then there's the Intihuatana, the carved granite pillar at the highest point of the site, whose name translates roughly to the place where the sun is tied. Archaeologists have long treated it as a ritual object connected to Inca solar ceremonies, and modern surveys have confirmed that its carved edges and surrounding stonework align closely with the position of the sun at key points in the year, including the solstices, a level of astronomical attentiveness that fits with what's known about Inca timekeeping more broadly, since the empire coordinated agricultural and religious calendars across a territory that stretched thousands of miles along. The Andes. It's a genuinely remarkable piece of observational engineering. It is not, as far as any peer-reviewed research shows, evidence of technology beyond what a sophisticated Bronze Age equivalent civilization with generations of accumulated astronomical observation could achieve. The honest version of this story is impressive enough without needing to imply otherwise. Put those 3 threads together, the DNA evidence of a deliberately assembled, empire-wide workforce, the LiDAR evidence that entire sections of the site remain unmapped, and the engineering evidence of infrastructure so precise it still functions 500 years later, and you get a picture of Machu Picchu that is genuinely more complex than the version most people grew up with. Not a quiet royal getaway. A logistical, administrative, and ceremonial hub built and maintained by people brought from every corner of an empire, sitting on top of engineering that modern professionals still study for lessons, with large stretches of its surrounding landscape still unexamined. That's the real headline. And it's exactly why what's happening next to it matters so much. For more than a decade, an airport project near the town of Chinchero, about 18 miles from Machu Picchu, sat in a kind of political limbo. First proposed in the late 1970s, revived multiple times since, and repeatedly delayed by funding disputes, contract disagreements, and changes in government, construction on Chinchero International Airport finally broke ground in 2018 and has continued in fits and starts ever since. As of early 2026, roughly a third of the construction is complete, with the Peruvian government now targeting a late 2027 opening. The airport is designed to replace Cusco's existing Alejandro Velasco Estate Airport, which is boxed in by the city around it and can expand. Chinchero, by contrast, sits on open highland terrain, and it's being built with eventual capacity for up to 8 million passengers a year, more than double what the current airport handles, and by most published estimates, enough to increase visitor traffic to the wider Machu Picchu region by something in the range of 200%. That number is the center of the controversy, and it has been from the beginning. UNESCO first raised formal concerns about the airport back in 2019, calling on Peru to pause construction until a proper heritage impact assessment could be completed, specifically evaluating what a dramatic surge in visitors would mean for Machu Picchu itself, for the historic center of Cusco, and for the Capac Nan, the network of Inca roads that also carries World Heritage status. Peru currently manages Machu Picchu under a strict daily visitor cap, somewhere between 4,500 and 5,600 people depending on the season, specifically because the site's stone pathways, terraces, and drainage systems, the same 500-year-old infrastructure described above, show measurable where from foot traffic, vibration, and humidity even at current volumes. Archaeologists and conservation groups have pointed out, reasonably, that a facility built to more than double regional visitor capacity is very difficult to reconcile with a management plan built around keeping daily numbers capped for preservation reasons. A carrying capacity study meant to assess exactly how much tourism the wider Sacred Valley can sustainably absorb has been in progress and is expected to inform policy through 2026, meaning a significant piece of the evidence needed to judge whether the region can handle Chinchero's projected volume is still being finalized even as construction on the airport itself continues. The local costs are already visible, independent of anything underground. Chinchero itself is a historic Andean farming town built around centuries-old terraced agriculture, much of it still actively cultivated. Reporting from the area has documented farming families selling off land as the airport project has advanced. Watershed concerns tied to Lake Puray, which supplies a significant share of Cusco City's water, and worry that waste management and water infrastructure in a region that's already strained will simply not keep pace with millions of additional annual visitors. None of this requires a conspiracy theory to be alarming. It's a documented, ongoing debate playing out in the open between a government and tourism industry that see the airport as overdue economic development for an underserved region, and a coalition of archaeologists, conservationists, UNESCO officials, and local communities who argue that the Sacred Valley's cultural and physical infrastructure, including the fragile drainage and foundation systems that have kept Machu Picchu standing for 5 centuries, simply was not built to absorb a threefold increase in traffic on an accelerated construction timeline. So here's where that leaves things, honestly. The last few years of research have shown that Machu Picchu is more complicated, more cosmopolitan, and more incompletely mapped than the story most people learn growing up. New DNA work has rewritten who actually lived there. New LiDAR surveys keep finding structures nobody knew existed in a park where the vast majority of the terrain still hasn't been scanned this way. And a deeper look at the engineering underneath the site keeps confirming that what's held it together for 500 years is more sophisticated than it gets credit for. At the exact same moment all of that is happening, an airport that spent a decade and a half stuck in political and financial limbo is now under active construction, aimed at more than doubling the number of people who reach this region every year, on a timeline that is running well ahead of the environmental and heritage assessments meant to determine whether the valley can actually handle it. Nobody needs to invent a hidden chamber or a secret cover-up to find that unsettling. The tension is right there in public records, in UNESCO's own statements, in construction timelines you can look up yourself. The open question isn't what's buried down there that somebody doesn't want found. It's whether the place that took 5 centuries to understand even this much will still be standing, structurally and culturally intact, by the time the research catches up to it, or whether the runway gets finished.